guys. Want to just go down the path of the ray tracing, compute ray tracing application, where we are dealing with um, a ray tracing scene, but we're using computation to do it, which means that we are not requiring ray tracing hardware on the GPU. We're doing everything mathematically, computationally. No ray tracing extension from Vulkan required, no specialized ray tracing hardware on our GPU required, which means that older hardware can run this application. So you notice that we're at about 29, 30 frames per second. We do have a shadow, and that shadow is created because we have a shadow test ray, which basically means that we shoot a ray from any particular region from that region to the light source. If anything blocks the ray, then we know we're in shadow mode. If nothing blocks the ray, then we know we are in light mode, so unshadowed mode. Okay, this requires extra processing. So notice that we're at about 30 frames per second. If I disable the shadow test in our application, if I disable the shadow test in our application and rerun the project, we will see that now we get about 44 frames per second. The application runs a lot smoother on the integrated graphics card. However, it's not as realistic because, alas, we don't show any shadows. There isn't as much processing being done. Okay, so this call is being done on the GPU side in the shaders. So these are the shaders, GLSL shaders. This is shaders are GPU side processing. And this right here, the source file, the .cpp file, compute ray tracing.cpp, is the CPU side processing. So we make this edit on the GPU side inside of the shaders in the GLSL, shader language that we use. And I will link a full video down below once I create that video, but just wanted to give you guys a little heads up of what's coming in the near future. This is Cuda Education. Have a great day.